First of all, we have to identify which angle we're working with in this equation. So that would be angle B, or 25. So that's this. Now let's label all the sides so that we know everything before we start really doing it. So first of all, opposite to this given, this is our question mark. So this is what they want us to find, AC, AC, and this would be our opposite. Good. Now we have to look at the other. So here we have our 90-degree box, or angle, and then that would mean that the side opposite to this is the hypotenuse. Now we're left with this side, and they've given us even how much it is, the length, so that means we have to use it in our equation. So this remaining is the adjacent side. Okay, so now we have our opposite, hypotenuse, and our adjacent. Now if we look at what they've given us CA, which is our AC, is what they want us to find out, and that's why there's a question mark. And they've given us the length of the adjacent side, which is 5. So they haven't given us anything on the hypotenuse, so we can just leave that for this equation. Now if we look at which function or ratio we can use to incorporate adjacent and opposite sides, let's look at it. There's sine, so opposite over hypotenuse, that won't work. There's a hypotenuse, we don't need that. We look at ka, our cosine, and that is adjacent over hypotenuse. Again, we can't use the hypotenuse. Then we finally come over to tangent, yeah. So toa, opposite over adjacent. So we have both sides, that can work. So we're going to be using tan. So tan 25 equals toa, so it's question mark, over adjacent, so 5. So this is toa, which is opposite over adjacent. So that is question mark and over 5. Now we can multiply 5 on both sides to get rid of the 5 on the other side to leave the question mark alone. So that would leave us with this equation, which will give us our answer of AC. So we have to put this in the calculator. So 5 times tan 25. 5 times tan 25. 25. And they want us, okay, so we got that, and they want us to round it to the nearest hundredth. So this would equal 2.33. Good job.
A central angle measures 4.5 radians and has an arc of 35 inches. What is the radius of the circle? So what's given to us here is 4.5 radians and the arc length, which is 35 inches. So we start by writing them here, the arc length, which equals to 35 inches, and the radians, which equals to 4.5. And what's required here is the radius. So we start by writing the equation, which is radius equals the arc length over the radian. So R equals to 35 over 4.5. And the answer is going to be 7.78 inches, which is our radius. The length of an arc is 18 centimeters, and the radius of the circle is 6 centimeters. What is the radian measure of the central angle? So to solve this question, first we need to see what's given and what's required. So what's given to us here is the length of the arc, which is 18 centimeters, and the radius of the circle, which is 6 centimeters. So here we write arc length equals 18 centimeters. And R, which is the radius of the circle, equals 6 centimeters. And what's required is the radian measure of the central angle. So first we start by writing the equation, which is theta equals to the arc length, which is S, divided by R, which is the radius of the circle. So it equals to the arc length, which is here, 18 centimeters, divided by the radius here, which is 6. So the radian measure of the central angle equals 3 radian. Here we have a question from the EmSAT. It says, which of the following radian measures is equal to 56 degrees? So here we need to change 56 degrees to radians. And this is how we do it. 56, we divide it by 180, and we multiply it by pi, which equals 14 over 45 multiplied by pi. So the answer is 14 pi over 45, which is B.
If sine theta equals negative square root of 3 over 4 and theta terminates in the fourth quadrant, what is cosine theta? So for this question, we will use the Pythagorean identity formula, which is sine squared of theta plus cosine squared of theta equals 1. The first step is you want to move sine to the other side and start from there. So you would have cosine squared of theta equals 1 minus sine squared of theta. So now you would want to write the fraction you've been given. Instead of sine squared theta, put down your parentheses and write the fraction. So negative square root of 3 over 4 and squared. If you put this in your calculator, you would get 13 over 16. This is not your final answer. So now you want cosine only. You don't want cosine squared. So how to do that is you square root your answer. So it would be cosine theta equals positive or negative square root of 13 over 16, which will give you square root of 13 over 4. This is your final answer. Since the terminal side of theta is in the fourth quadrant, the cosine would be positive.
So the question says, if sine theta equals negative square root of 3 over 4 and theta is located in the fourth quadrant, what is cosine theta? So we know that the equation is cosine squared theta plus sine squared theta equals 1. In this case, we need to find cosine. So what we're going to do is we're going to put sine here. It's going to be cosine squared theta equals 1 negative sine squared theta. And now you're going to begin solving. So here you're going to put 1. You're going to put sine in a bracket. Squared. You're going to put this in your calculator and you're going to get 13 over 16. So you are going to do square root of 13 over 16 and you're gonna get square root of 13 over 4. That's gonna be your final answer. Cosine is in the fourth quadrant and so it's gonna be positive. So your answer is gonna be B.
An example is log base 4 of 16. This is how it's read. Log base 4 of 16. To evaluate this logarithm, the first step is to set it equal to y. So log base 4 of 16 equals y. Second, write it in the exponential function form. The base is 4, the exponent is y, equals to 16. So 4 to the power of y equals 16. You can just think of an exponent that when 4 is raised to gives you 16. Sounds like 4 to the second power equals 16. Therefore, log base 4 of 16 equals 2, because 4 to the second power gives me 16. Here's another logarithm to evaluate. First, set it equal to y. Log base 7 of 7 equals y. Second, write it in the exponential function form. The base is 7, the exponent is y, equals to 7. 7 to the power of y equals 7. Now think of an exponent that when 7 is raised to gives you 7. A number would equal itself in an exponential function. F and only f, the exponent is 1. So y equals 1 and 7 to the power of 1 equals 7. Therefore, log base 7 of 7 equals 1, because 7 to the first power equals 7. Here's one more logarithm to evaluate. Log base 5 of 1. First step is to set it equal to y. Second, write it in the exponential function form. The base is 5, the exponent is y, the answer is 1. 5 to the power of y equals 1. Now think of an exponent when 5 is raised to gives you 1. A base of a power would equal to 1 if and only if the exponent is 0. So y equals to 0, 5 to the power of 0 equals 1. Therefore, log base 5 of 1 equals to 0, because 5 to the 0 power equals 1. We conclude that a logarithm is an exponent. In other words, the answer to a logarithmic function is the exponent in the exponential function.
The table above shows the genders of students who visited a youth club over 5 days. If one student is selected randomly from the club members, what is the probability that the students will be a boy or be on Wednesday? Option A, 0.868. Option B, 0.763. Option C, 0.632. And option D, 0.237. Let's find out the correct option. At first, find the probability of a boy or Wednesday. Probability of boy or Wednesday. These two events are not mutually exclusive, so we'll have to use the probability of a union formula to solve this question, which is the probability of a boy or Wednesday equals probability of a boy plus the probability of Wednesday minus the probability of a boy and Wednesday. The probability of the boys is the total of 24 over the total number of students in the youth club plus the probability of Wednesday is the total students who attended on Wednesday. 9 students attended over the total of 38 students minus the probability of boys and Wednesday is the total of boys who attended on Wednesday. 4 boys attended over the total of 38 students. 4 over 38 students equals 29 over 38. To convert it to decimal, the correct answer is 0.763. Since we converted 29 over 38, the correct option is B, 0.763. What is the probability of tossing 4 coins and getting exactly 2 heads? At first, we have to find the probability of exactly 2 heads. Let's find out how many of the total possibilities have 2 heads of the total of equally likely possibilities. The probability of exactly 2 heads. So we know there are 16 equally likely possibilities. How many of those have 2 heads? To save time, I've drawn all of the 16 equally likely possibilities, and how many of these involve 2 heads? Let's find out how many of those involved 2 heads. This one over here has 2 heads. This one over here has also 2 heads. This one over here has 2 heads. This one over here has 2 heads. This one over here has 2 heads. And this one over here has 2 heads. So if we count them, we have 1, 2, 3, 4, 5, and 6 of the possibilities have exactly 2 heads. So 6 of the 16 equally likely possibilities have 2 heads. The probability of getting exactly 2 heads equals 6 over 16. So we have a 3 over 8 chance of getting exactly 2 heads.